Hi, I'm Harish Kumar Srinivasan. I'm gonna solve homework 6 first question. The given question is they've given the joint density function of x and y, which is nothing but a into 1 plus xy, which and x and y are defined between -1 to 1, otherwise 0. Now, the first part of the question is finding out the value of a if the given joint density function is a valid density function. So we know that if it is a valid density function, then summation over all x and integration over all x and integration over all y, all values of y should be equal to 1. So we have applied that identity to find out a. I have already solved it. I'll just explain you through the steps how I got this answer. So this is the like I said, this is the joint density function, a into 1 plus xy. So the first part of this question is to find the value of a if the given joint density function is valid. So like I said, this is the criteria we are using, and integrating the f of xy joint density function for all values of x and for all values of y, with x and y are defined only from -1 to 1 given in the question. So integrating initially with respect to x gives us value 2, then integrating that resultant with respect to y will give us a is equal to 1 by 4. This is the solution for the first part of the question. The second part of question is to find the mean of the joint density function, so which is number e of xy. So we know that to find a mean, we just put whatever is inside the bracket into f of density function and integrating for the all values of x and y. So we have did the same here. Xy into this is nothing but joint density function. So whatever is given inside the bracket into f of x y and integrating it with respect to x as well as y. So doing this, we get e of xy to be 1 by 9. I haven't written it here clearly, so 1 by 9. So with this we aren't done with the second question. We are yet to find if x and y are correlated. Uncorrelation is found if e of xy is equal to e of x, e of y, then x and y are uncorrelated. So we just try finding e of x, which we are getting as 0. So here it makes no there is no way this identity is gonna stand. So this is in this case this will become not equal to, and so they are not uncorrelated. X and y are not uncorrelated. With this, I'm done with the second part of the question. The third part is if x and y are we got to find if x and y are independent. We know the property for independence of two random variables to be the joint density function should be equal to the product of individual density function of each random variable. So applying the same whatever I told just now here gives us will tell us if x and y are independent. So initially finding f of x, density function of x. The density of function of x can be derived from the joint density function of x and y by integrating a joint density function with respect to the other variable, which is y. So which we have done and got it to be 1 by 2 and 1 upon 2. And the same way y random variables density function can be found by integrating the joint density function with respect to x, which is the other variable of y. So which will also result in the same value as f of x, which is 1 by 2. But f of xy is not this doesn't stand in our case. We know that f of xy is, joint density function is 1 by xy is not equal to 1 by 4. This is not equal. So in that case, x and y are not independent. So we derive, we found the individual density function, and we found that it's not equal. Their multiplication is not equal to the joint density function, so it's not independent. So I'm done with the third part of the first question in homework 6, and the last part is we are given with two functions. Z and y are given random variables, and the random variables are equal to the square of the earlier random variables which we were dealing with till now. So we got to figure out the joint density function of z and w. Here considering both the situations, both the functions, and collectively we get it. Collectively it'll have 4 roots. So using the Jacobian method to find out the roots, we get it to be Jacobian rule is to find out the relationship between the relationship between z and w. So here in this case, for xy is what we have got, and x and y in terms of z and w is written here. As we know that x and y are defined for -1 to 1, so in this case, as z and w are even functions, so it will be defined from 0 to 1. So that's what is given here. And as we have 4 different roots, the normal root, this is like the general function, root, and different cases will be substituted to get the different roots. We also know that if we have some random variable density function, if we have to find the other random variable density function, we know that we just got to substitute the variable in terms of our interested random variable divided by the roots. So here, as we have 4 roots, so we will be summing all the 4 different cases, and we finally arrive at the solution that f of joint density function of z and w will be 1 by 2 root z into 1 by 2 root w. So, and for all other values it's 0. So with this, I'm done with the last part of the first question, and here is the end of my first question and solution. Thank you.